Hi everyone! Welcome again to my channel, Math is Fun channel. This is an educational channel to help you understand and love mathematics. And this is intended for those who are doing the online classes out there and also the who are answering their modules. This channel will help you understand your lessons and topics about mathematics. You like that? I want that. It sounds so interesting and exciting. So please do not forget to watch the video before you subscribe. And please do not forget to click subscribe and like and share this video to your friends and classmates, especially those who are in need of this channel to help them improve their skills and performance in mathematics. So I hope everybody will share this video to those people who need this video. So I am expecting that one that you're going to do it. And again, do not forget to click subscribe and please watch first before you subscribe. Okay, so now let's get started. Let's now start about our video discussion in this session. So are you ready? I am also ready and so excited to learn new things for this in this video discussion. So please do not forget that math is fun. That is really my advocacy to really help you change your perspective that math is not a difficult subject, but it is a fun and interesting. So now I'm going to share our topic for this. This is under intermediate algebra. It's still part of algebra, of course. So our topic will be linear equations. I know most of you have already encountered about linear equations. What are linear equations? What's this topic all about? Let's discover. So when we say linear equations in one variable, this is our main objective or our main focus in this video discussion about linear equation in one variable. So let's be guided with the objectives. Of course, the first one, we're going to decide whether a number is a solution of a linear equation. That's our first objective. Our second, solve linear equations using the addition and multiplication properties of equality. And third, solve linear equations using the distributive property. And also solve linear equations with fractions or decimals. And lastly, identify conditional equations, contradictions, and identities. Oh, it sounds interesting, right? So excited. Okay, so of course, first, let's try to differentiate and compare between the difference about algebraic expressions and equations. What's the difference between expressions and equations? Do you have any idea? Oh, I love the music background. Okay, so what's the difference? So in the previous chapter, we looked at algebraic expressions as this: negative 9y, as you can see, plus 5, 10k, and a over negative 7b squared c to the power of 5. So these are algebraic expressions that we encountered before this topic or before this video discussion. So when we say equations, these are statements rather, that two algebraic expressions are equal. So in short, the only difference in here, later we will discover perhaps, in equation there is an equal sign and in expression there is no equal sign. So now, in equation we have 3x minus 13 is equal to 29 as our examples. We have 2y plus, or 2 plus y rather, is equal to negative 11. And 3m is equal to 4m minus 2. So these are examples of equations. So an equation always contains an equal sign. So this is what I said. An equation has always, or it contains an equal sign always, but an expression does not. So what's the difference again? I'm giving the difference, the easiest way to differentiate between the two so that you will not forget it. In equation, there is always an equal sign, but in expression, it does not use equal sign. So that's it. Very simple differentiating between the two. So now, after differentiating them or comparing them, we can now proceed to linear equation in one variable. How do we define linear equation in one variable? I want you to read there. A linear equation in one variable can be written in the form of ax plus b is equal to c. where A, B, and C are real numbers, with A is not equal to 0. What will happen if A is equal to 0? This become, this will be eliminated. The first term becomes 0. So that means there's no variable. Correct? So it's not anymore a linear equation in one variable if a is equal to 0. That's why our restriction in here is your a must not be equal to 0, or else your linear equation will not be what? Your linear equation will not be a linear equation in one variable, of course. So that's the reason why your a must not be equal to 0. So that's the restriction. Okay, going or continue. Let's continue. Again, do not forget, linear equation in one variable can be written as ax plus b is equal to z, where c rather, where a, b, and c are sets of real numbers. So a linear equation is also called a first degree of equation. Why? Because the greatest power on the variable is 1. That's why we only have one solution or root for linear equation. Again, it is written in the first degree of equation since its greatest power or degree is 1. So now, let's determine whether the following equations are linear or non-linear. So 8x plus 3 is equal to negative 9. Is it linear? Yes, it is because x is raised to the first power based on the definition. Another, 9x cubed minus 8 is equal to 15. Oh, it is not linear. Why? Because x is not raised to the first power. What about, oh, excited. What about the second one? Is it linear? 7 over x is equal to negative 12? Let's try to think. No, because x is not raised to the first power. It is in fractional form, but you can rewrite this one in linear equation in one variable form, okay? This one, square root of x minus 4 is equal to 16. Linear or not? Oh, it's not linear. Why? Because x is not raised to the first power. So I want you to remember how to identify whether the equation is linear or not. Again, linear equation is in the form of ax plus by is equal to z, and it can be called as, or we can call it as the first degree of equation. So the highest degree of its variable is 1. Okay, deciding whether a number is a solution. This is part of our objective for this video discussion, or in this video discussion rather. If a variable can be replaced by a real number that makes the equation a true statement, then that number is a solution of the equation x minus 10 is equal to 3. So when we say solution, in deciding whether a number is a solution or not, when you substitute it to the equation given, the value of your, any value of your variable, and substitute it to the given linear equation, when the left side of the equation and right side of the equation will be equal, that means the statement is true. When the statement is true, it is said that the the variable, the value that you substituted is considered as a solution of the linear equation. Now let's try to check this out. 13 is a solution. Okay. Again, our equation is x minus 10 is equal to 3. Let's try to substitute. How to substitute? Just replace the value or the variable with a value of 13. So we have it 13 minus 10 is equal to 3. Then solve for the left side of the equation. So 13 minus 10 is 3. Therefore, 3 is equal to 3, and that makes the statement true. So 13 is a solution. What about 8? Why is 8 is not a solution of x minus 10 is equal to 3? So substitute to the given equation, x minus 10 is equal to 3. Then you have it, a minus 10 is equal to 3. We all know that 8 minus 10 is 8 minus 10 is not equal to 3. That's false. Why, sir? Again, to solve this one, the left side becomes negative 2, and it's not equal to 3 anymore. So that's why the statement is false. So that's why 8 is not a solution. So easy, right? Yeah, it's just very easy. Just follow the definition. The definition is our basis. So finding the solution set of an equation. Now this time, after knowing how to decide whether the given value is a solution or not to a given linear equation in one variable. Now let's try to find solution or the solution set of an equation. So always remember that an equation is solved by finding its solution set and the set of all solutions. Okay, we call that solution set as the set of all solutions. Sorry. Okay, the solution set of x minus 10 is equal to 3 as what we solved a while ago is 13. So equivalent equations are equations that have the same solution set. So sir, is it possible that there are equations that have same solution set? Yes, we call them as equivalent equations. So these are equivalent equations since they all have solution set which is negative 3. So let's have an example. This one. So we all know that 3x plus 5 is equal to negative 4 and 3x is equal to negative 9 when x is equal to negative 3. Therefore, they have the same solutions. Let's try to solve. This one, we just substitute negative 3 in here. So multiply negative 3 by 3. That gives you negative 9 plus 5, which gives us negative 4, correct? So this one is a solution to this equation. What about in 3x minus 9? 3 times negative 3 equals negative 9. Yes, it is negative 9. So this is a solution to this equation. So meaning to say 3x plus 5 is equal to negative 4 and 3x is equal to negative 9. Both of them, these two equations are, we call it equivalent solutions. Equivalent equations. Why? Because they have the same solution set. So I want you to remember that one. It's easy to remember, right? Okay, so now let's try to identify or illustrate solving linear equations. An equation is like a balance scale, comparing the weights of two quantities. So as you can see there, expression 1, we have which is equal to expression 2. Again, an equation consists of expressions. Okay, without expressions, equation cannot be, or it will not exist. Okay, so as you can see, we apply properties to produce a series of simpler equivalent equations to determine the solution set in order to make the scale be balanced. Okay, so we have variable is equal to solution. You can illustrate in that way or manner. So in addition property of equality, the same number may be added to both sides of an equation without changing the solution set. So this is the illustration of addition property of equality. A is equal to B. So A there on the left side and A on the right side. And of course, you are going to add something to your A and your B to make them balance. So we have it A and B, A on your left and B on your right. Then we can add any values or any numbers or constant terms to your A and B so that both left side and right side of the equation will be balanced. So that's the concept of addition property of equality. You're going to add both sides of the equation so that the equation will be balanced, so that x will be left or variable will be left on the left side of your equation. So another illustration for or another property, which is multiplication property of equality. These these properties that I am introducing right now are used to solve linear equation in one variable. So each side of an equation may be multiplied by the same non-zero number without changing the solution set. So same thing in here. When we have A is equal to B, expression is equal to expression. So A on the left and B on your right. So we can multiply any number or any values or constant terms to both A and your B so that the equation will be balanced. So this is how we illustrate. So A and B, so we multiply it by C so that they will become balanced. So now addition and multiplication properties of equality. This is our standard properties or definitions according to its rules. Its rule rather, addition property of equality for all real numbers A, B, and C, the equation A is equal to B and A plus C is equal to B plus C. They are equivalent. Okay? So multiplication property of equality for all real numbers a, b, and for c is equal to 0. The equation a is equal to b and a times c is equal to bc. So they are equivalent. So that's how we use the multiplication and addition property of equality. And again, the purpose of that is to make the equation balanced and to find the value of your variable. So addition and multiplication properties of equality, because subtraction and division are defined in terms of addition and multiplication, then we can also say that a minus b is equal to a plus negative b. And a divided by b is equal to a times 1 over b. So we can extend the addition and multiplication properties of equality as follows. The same number may be subtracted from each side of an equation, and each side of an equation may be divided by the same non-zero number without changing the solution set. So we can now have the steps in solving linear equation in one variable by applying the properties that I mentioned a while ago. So step one, clear fractions. Okay, so clear fractions, eliminate any fractions by multiplying each side by the least common denominator. This is applicable for fractions. Again, step number two is simplify each side separately. Use the distributive property to clear parentheses and combine like terms as needed. And step number three, isolate the variable terms on one side. Use the addition property of equality to get all terms with variables on one side of the equation and all numbers on the other. Also, sorry, because the dogs want to really join with us. So let's just recognize their presence perhaps. Wow, amazing. Okay, step number four, going back. Step number four, isolate the variable. So isolate the variable, use the multiplication property to get an equation with just the variable. So with coefficient of 1 on one side. And of course, last, step number five, we have to check, okay? We can check the equations by substituting the proposed solution in the original equation. I want you to read and I want you to study the steps and we can follow the steps in order to solve linear equation in one variable. Wow, the dogs are very noisy. They really agree with our steps, perhaps. They want also to learn mathematics, okay? So funny. Okay, next now. Let's try and let's go to the application. So now, solve 3x plus 2 is equal to 10. So how do we solve? 3x plus 2 is equal to 10. So we subtract 2, applying the subtraction property of equality or addition property of equality. Then we have it, 3x plus 2 minus 2 is equal to 10 minus 2. And that gives us 3x is equal to 8 by combining like terms. Then you have it by dividing both sides by 3, then it gives us x is equal to 8 over 3. So that's our proposed solution. So now let's try to check with our proposed solution. What's our answer a while ago? 8 over 3. So using the given equation 3x plus 2 is equal to 10, then we can multiply it or substitute the 8 over 3 to your variable x. That's why we have it 3 times 8 over 3 plus 2 is equal to 10. Check by substituting the proposed solution, which is 8 over 3, back into the original equation. Then, to solve, of course, to multiply 3 times 8 over 3, that gives you 8 plus 2 is equal to 10. Since the value of each side is 10, the proposed solution is correct. So the solution set is 8 over 3. Very easy, right? Okay, let's have another example. So another example is 2x minus 5 is equal to 5x minus 2. Then you have it there. Of course, we subtract 5x to both sides of the equation. So we can have now, by combining like terms, negative 3x minus 5 is equal to negative 2. Then you have it add 5. So negative 3x is equal to 3. That gives you negative 3x is equal to 3 by combining like terms. And after that, what will we do? Divide both sides by negative 3 and that gives you x is equal to negative 1. So that's our proposed solution, negative 1. So if we want to check it, again, go back to the solution, to the original equation and substitute the proposed solution, which is negative 1, as you can see in the blue mark. So 2 times negative 1 is minus 5 is equal to 5 minus 5 times negative 1, quantity minus 2. So that gives us, since the value of each type is negative 7, the proposed solution is correct. Therefore, the solution set is negative 1. Very easy. Okay, what about this one? Oh, it is getting it is getting like challenging. So it becomes more challenging. So we have 5 times the quantity of 2x plus 3 is equal to 3 minus 2 times the quantity of 3x minus 5. So what will we do is, of course, we distribute or using the distributive property of multiplication. So you have it 10x plus 15 is equal to 3 minus 6x plus 10. So you have it add negative 15 to both sides of the equation and combine like terms. Then you can have it 10x is equal to negative 6x minus 2. Then you can add both sides by 6x so that we can combine like terms for the variables or terms having variables. Okay, so we have it by combining like terms that gives you 16x is equal to negative 2 and divide both sides. Okay, from 16x is equal to negative 2, divide both sides by 16. And that gives you proposed solution as x is equal to negative 1 over 8. So now to check the proposed solution, as you can see, just substitute negative 1 over 8. And as you can see, the solution set is negative 1 over 8. Since the proposed solution, when you substitute it to the original equation given, the answer or they can give us a true statement. Okay, so that is also great. There are a lot of music or background music outside, perhaps. So now we can solve linear equation in one variable. So that's it. We will end our discussion in here. So I hope you have learned a lot of things about solving linear equation in one variable. Just do and follow the steps. And also, of course, please follow the properties because we have the properties to follow in order to solve the linear equation in one variable, to solve the solution rather of linear equation in one variable. So that's it. We will end our topic in here and we have a more topic next video discussion. And I hope everybody will continue to subscribe and to watch my videos. And of course, always remember that math is fun and math is not a difficult subject. It's easy, fun, and interesting. Please do not forget to subscribe my channel and share this one to your friends. Thank you and have a good day.